Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Ham Nation is provided by Cachefly at CACHEFLY.com.
This is Ham Nation, episode number 14, August 23rd, 2011. Leo builds a dipole. Welcome to Ham Nation. And again, they're always special, but this one, oh my. We're all back from the great opening of the Twit Studios, and let's see if everybody's alive. Gordo, did you make it home okay?
I did make it home, and what a great time we had at the Twit Brick House.
We were so glad to have you. It was so much fun to have both you old Elmers holding my hand.
And there is our new general, W6TWT.
And thanks to Ray and ICOM for this great banner I can hang over the ham shack now.
Isn't that great?
Isn't that great? And yes, I got my general.
Hey, General. Hey, all right.
I'm stroke AG, as they say.
We go to lunch. All of us are having fun at lunch and talking about all kinds of things. What's Leo doing? He's over in the corner with his phone taking the test online because he knew he was going to do the general.
But I was nervous, and I didn't need to be, I guess. I passed.
No, you passed it with flying colors.
I didn't. I wanted to catch up. Now I'm going to stop for a while. I'm going to get that extra later because that's what Gordo says. He says, be a ham for a while now. Enjoy your... That's right. Enjoy your ray. But the main reason I wanted to do it is I wanted to get on the high frequencies, Bob. Yeah. I wanted to be able to use that ICOM 7800, the beautiful radio.
We could just talk and talk and talk about all this stuff that went on, but I'm sure that all the shows will cover this. But what was really special about this is you passed the general. You've got all that gear in the corner, and you said to us that day, I'd like to know how to build a dipole.
Yeah, we did, right. I think. Are we going to do that?
We did.
We taped it.
We taped it. And I think we should fire that baby up and show how to build it. What do you think? What do you think, Gordo? You think we should do that?
I think he should. Let's build that dipole.
Let's build the dipole.
You know, we're still learning.
I'm sorry.
And we've decided that purple is the color for Ham Nation?
Yeah. Purple, Heil purple.
Heil purple, oh yeah. He only wears purple sneakers.
Well, not today, but there's the stories.
He's orange today.
Yeah, that's right.
Orange today. Boy, this has been fun, I have to say. This has been so cool. We had so many great hams. Yeah,
and it's really a great celebration of your general license. I just can't tell you.
Well, you know, it kind of worked out perfectly because the Mount Diablo, thank you.
Yeah.
The Mount Diablo Amateur Radio Club does testing on the third Friday of every month. Mm-hmm. So it was the third Friday last month. I got the technician. And then I knew that we were going to be doing this on the 20th and 21st. And I knew that we were going to have HF radios. We wanted to use 20 and 40. And I thought, well, I got to get my general. So I've been studying like crazy, and I'm so pleased. So now I can use these radios.
We go to lunch yesterday, and we're all talking about things and having a great conversation. What he's doing, he's sitting here with his phone.
The practice exam.
What's the length of a dipole on? And
intense studying.
Intense, right? We could just, but that's
well, you know, you get Gordo West sitting next to you. You gotta say, hey, Gordo, what's a Schottky diode? What is a beverage antenna? And so you got the guy here. I had all the answers. And you know, it was fun because we also had a number of extras with us, and they were explaining things like why you want to get the antenna at a certain height, you know, half wave above, so you don't smush. You don't smush the figure eight and all that stuff. So actually, that helped me a little bit understand what I was doing.
Kirk Karnak was there, and he answered a couple of those too. So there you go.
Guess who else got his general today, thanks to you and your VEs?
That's right.
Kirk Harnack of our show This Week in Radio Tech, who's been a technician for a long time. And he said, Leo, if you fail on Friday, we'll come back. And Gordo said, well, we can give you a second chance on Saturday. Fortunately, I passed, but you gave Kirk his test. And so,
yeah, there's a lot of VEs here today. So
that's really great. It's so much fun. So we're going to make a dipole.
You've been asking to do this, and I said, well, we could do it on the air. George and I have talked about doing it on the smoke. I said, no. When we're all together, we're going to do this with everybody so we can show you how easy it is.
The dipole is about the simplest antenna there can be, right? It's half wavelength, 2 quarter wavelength lengths of wire.
The stuff's stuck.
Connected in the middle. Now this makes it a lot easier because this is a junction that does the hard part. So you connect each of the quarter wavelength ends to these terminals, and there's the coax connector.
If we had
feed point.
Feed point, is that what this is called? Feed point. Okay.
If we just had
Like
the coax connector, we could solder a wire to the tip in the water here, but it wouldn't be very good as far as substantial physical strength.
This is strong,
Right.
and because it's got these holes, you could screw it down, and you can make it pretty sturdy.
This wire goes inside is the center, and
Okay.
this goes is the outer. So all we have to do is complete it with the wire. So we're going to let's do a 10-meter one.
All right.
10 meters, okay.
10 meters, okay.
About how long would it be for a half wavelength of 10 meters?
Well, I multiply by 468, right?
Okay, sure, that'll do 468.
And then I'll give it to
by
me
the
in feet.
frequency in megahertz.
Yeah,
right?
by the frequency. So
In
10
megahertz.
meters
28.
is 28 times, I need a calculator.
Here you go.
Here we go.
Here you go.
468.
468 times, that's 0.468, so we'll have to move the
Wait a
decimal.
minute.
468 divided. He means
Divided, not
Let
times.
me do this.
Divided.
Okay. Here
Yeah,
we go.
otherwise it'd
All
be
right.
awfully long.
Yeah,
It'd be taller than the Empire State Building.
Okay, we put in
468 divided by 25 megahertz. Is
Let's
that
do
right?
28.
28?
Yeah,
Okay.
25 is sort of fun, but 28 is even more fun.
It's,
Okay.
it's halfway there.
Yeah.
And so we're going to do 28.
28,
Let's do
okay.
28.4.
Equal
Okay.
sign.
Equals. That's
There we
16
are.
feet.
16 feet.
16.47 or 16 and a half feet.
End to end.
So we should do 2, 8, and a quarter.
Cut it in half, right.
Yeah.
So divided by 2.
Although the easiest way to do this would be to have a 16 and a half foot wire and just cut it in the
Cut it
middle.
in half.
Oh, wow. I never thought of that.
Because don't you want to be pretty accurate on this? I mean, you don't. How
close.
How tight are the tolerances?
About a half inch.
About a half inch.
Well, that's pretty
Yeah.
tight.
So we're going to make this 8.24 inches.
All right. So, and do I allow for the
Everything.
the leads,
And the end.
Let's make that 8. Okay. Yeah, 8 point. Okay.
8.24 feet.
Yeah, there you go. Yeah,
So there's
not
3
inches.
feet.
That's it.
me,
This is good.
Pull this up.
Well, this is precision.
Okay. I'll hold it here.
A yardstick.
Okay.
I'm sure there are better ways to do this.
No, you got to understand that there's a lot of people that we don't have all the.
Okay. This will be 6 feet.
There's 6.
That's 6.
There's 6 right there.
All right.
Now it gets complicated.
Now it
Yeah.
gets.
Now we got 2 and a quarter, 2 and a half.
But I put a little mark there for you.
Oh, look at that.
Look at this.
24 inches right there.
Right there.
Plus 6 inches makes 30. And
There's
24.
8, and we want 2
So right there, get those dikes out. We're going to cut it at 30, right? Is that
right
right?
into here.
Or 29?
It's 24. That'll be
24
8,
plus 6, right?
and it's a quarter.
Quarter.
So we're going to cut her right.
You always want to make that dipole a little longer so that
Oh, you do. Longer's
can
okay.
Let's put
yeah,
one
you
more
can
inch
begin
on
to
it.
shorten it.
All
Okay.
All right, now the scientific part. You hold on to this one,
Okay.
onto this one,
Okay.
and I'll hold on to this
And
one.
we pull. Okay, and whoever
Is
gets
this
there first
great?
gets his wish. Oh, this is clever. By
What
doing
a
it this
way.
way, we didn't have to bend it in half or anything. Look at that.
Amazing.
They're pretty cool, isn't it?
But now, and I'm curious because this is speaker wire, right? And isn't the insulation on the speaker wire going to get
It
in
is
the way?
not a bit.
Not a bit. Okay. All right. And you were saying about number 12 gauge wire would be about what you'd want.
I like to use number 12, like copper solid wire. It's physically really great, so
Okay.
it's not going to have a lot of
So we don't
problems.
have to do strip it or anything. We just got the ends
no, we
there.
did
We've
that.
got these.
I'd use that in because it's already straight.
Yeah. And then we leave the other end the way it is.
Yeah.
Huh?
Right.
All right. And then we're going to put these,
Not yet.
not yet,
Put it through here.
put it through this hole.
We're gonna make-
Strain relief.
Because we want to, oh yeah, we want a strain
Do it
relief.
through
all
there a
right.
couple times.
A couple of times?
Wrap it up there
Okay.
again.
It's called a double strain relief.
There you
All
go.
right. All right. And then on the thing, but I'll tighten this end up here.
Now, George, what do you think? Should we crimp it or should we solder it?
You should do both.
Both.
We should do both. Okay. So crimping and soldering a lug
But we don't have a lug.
Well, we don't have a lug, but normally...
we just twist it around there then.
Yeah.
Okay, twisted around.
Now,
But
one thing I know about solder, of course, is if the lightning hits it, it's just going to melt that sucker. So crimping, you got to crimp too,
That's
right?
right. That's right.
That's in the test tube.
That's right.
In the general exam.
That's
All
right.
Okay,
On
here
grounding.
we go.
That's right.
So we're going to go once for strain relief. We're going to go through twice. Tighten that down there.
Pretty neat, isn't it?
It's not too hard. And this is actually going to be, for that wavelength, a very good antenna,
Just
right?
a minute. You did that wrong.
What did I do wrong?
You wrapped it backwards.
You want it inside?
No. I'm talking about this.
Oh,
When you put this...
when you tighten up the
this
screw.
bolt,
you want to do it
so it tightens up with it.
counterclockwise so that the screw tightens
right?
it in.
Yep.
There you go.
Smoke and solder, baby.
with me?
I'm with you.
Why we did that?
I completely understand because I'm turning the screw clockwise, so you want that
want that to be
attachment the other way.
Otherwise, it gets all messed up.
You know, I'm not getting it
Funky.
as tight as I'd like here.
Well, we need to get some...
We're going to solder
wrenches
that a
and all
little bit.
Yeah, we would have done all that. I just wanted to get
But
that
that's
on
good.
for
That's a
the
good
show.
connection. There you go. Can
There
we
you go.
see that? There you go. So we've got the strain relief here, so it's pulling right there. Pulling right there. It's not going to pull that out.
Now, George, and... There we go. George, and... Yeah, you got that okay? Okay, cool.
Now, I know this is supposed to be...
Here, hold this, Gordon.
Pull it tight.
Tight. There you go. Now,
There you
what we
go.
would do
Pull
here
the dipole.
is we would
Hang that.
in the center.
Now, you want it slightly above
Right.
the ends, right? You want
We
them going
could-
down. What angle do you want
Well,
for that?
we could make it a flat top. Pull that straight, guys. Pull it straight. We could make it a flat top,
Okay.
or we also could make it what we call an inverted V.
And now, is there a reason that you would do inverted V?
Oh, yeah.
Why is that?
It'll give radiation off the ends beside the flat side.
Aha.
Now, more omnidirectional.
Aha. So if you wanted it more directional, you'd get it straight.
Right.
And more omni, you tilt them down a little
Correct.
bit. All right.
There's
that's
also one little other sidekick of that thing, and I note sometimes, especially with things on 75 meters, is it takes a little less space for an inverted V, right? And I know a lot of my friends that try to put up big 120-foot dipoles, maybe they only have 110 or 100. They can...
So it's horizontal, less
But
horizontal space.
You can't
yeah.
get it too close to each other.
Just
It's gotta
a
be
slight angle.
90 degrees, no more.
No more.
nor
Okay, it
less.
can't be a right angle.
Yeah.
Now,
That's-
George, what do you recommend for the end, remembering that you can get some high voltage right here, huh?
Well, I would put an insulator on there, and then I would tie me a rope or whatever I wanted to use to support it with on out to a tree limb or
you
support.
get nice and tight there. That
So
way.
you've got an insulator there so that you're not getting any RF over into whatever's holding it out here on the end. It could even be another piece of wire as long as it's a non-resident.
Rated. And I usually leave a little pigtail like this, and then with my SWR analyzer, I'll sweep it. And if I'm down at 27.9 instead of 28.4,
You can
we need
just-
to shorten it
Got
up.
it, got
We
it.
can either cut, or the way I do it is I just wrap it around on itself, and now it's like shortening it. So
Uh-huh.
you always want to make it a little on the long side so you can
Cut it, to
shorten
tune it a
or
little bit.
cut it. That's good.
Yeah.
It's hard
Wow,
to
that's
uncut
great.
it.
It's hard to uncut it. Adding to it. Yes.
Now, of course, you want to keep this somewhere where kids and animals can't touch it. Although the
Absolutely.
insulator is good. I mean, if a dog came along and peed on it, you'd still be all right because the insulator would keep them from.
We would. The dog would probably hurt for a little while. And you know, the dipole is unity gain. So all of these other antennas that have loading coils are actually slightly less efficient
Right.
than the dipole. And we made this out of your speaker wire downstairs. I mean, we literally
right.
stole it. So
We did.
tomorrow when something doesn't work,
Well, no, why?
we got the wire.
I can't hear my speakers. Well, we got a great 10-meter antenna, however. That's great. So now you want to. I remember this also from the test. 1/4 to 1/2 wavelength up in the air. Is that right?
Correct.
That's
Yeah.
where it should be.
So not too close to the ground because you don't want to smush the
get it high.
figure eight.
Right.
But and higher is okay.
Hire's
It's just
generally
a
okay.
minimum of 1/4 to 1/2 wavelength off. the
Always
ground.
watching for power lines.
Yeah, of course.
Stay away from power.
Very
Yeah.
important. But there are times when higher's not always better. If you want to
Talk in close.
If you want to talk in close, you want to keep it a little lower. So it depends on what you want to do, you have to decide what kind of operation you're going to do. If you're going to go for the long-haul DX work, get it up a wavelength or two.
We were talking about somebody who wanted to talk to somebody nearby. He actually put it close to the ground. It almost turns into a NVIS, an NVIS antenna as it gets closer to the ground. It's vertical incident, right?
Exactly.
Yeah.
Man, that general stuff.
I have no idea what I just said.
That was a great lunch yesterday.
Yes, you do.
Yeah, I love this stuff. It's really great. So now this goes to coax, right?
Correct.
Is that an N junction on that?
That's a PL.
That's a PL.
SO239.
Okay. And I do remember that water is one of the things we really want to keep out of our coax. So we're going to put a little coax seal around the end of that to keep water from getting into that coax.
That's what it's called. Coaxial comes out of Reynoldsburg, Ohio, and it works great.
Yeah.
All right. So
good stuff.
we'll get some of that too.
Yep.
And then that coax can go right into the ham shack and right into our radio. That's it.
That's it.
Well, that's pretty darn good.
That's pretty simple.
Now you just make one of these for each wave, each band you want to participate on, and you're set.
You got it.
Or you could actually run more radials off this same set here and make a multiband
Good
antenna,
point.
couldn't you, Gordo?
So I could put another one in here that, let's say, would be for the 20-meter band.
16 feet long.
Connect it to the same poles.
Same pole.
I don't have to do anything. I don't have to.
No.
No?
That's why
it.
those are longer, so you can.
There's more room. Well, that's pretty good. You can get a nice little star set up out there in the backyard, and you'd have all the bands you wanted.
A while ago, when I turned my remote on for you back home, we listened to I call it a bow tie. It's 120 foot for 75,
right,
and 66 for 40, all on one of these. There's two of them, one 120 and one.
Oh, that's really cool. Bow tie.
And so when I switched to 75, the transmitter says, "Oh, I'm resonant here."
Right.
When it switches to 40, "Oh, I'm resonant here."
So it just knows. It just electrically goes the way it needs to go.
Well, it's resonant.
It resonates at the right frequency.
Right, and that transmitter is looking for a resonant frequency.
Got it.
And when it finds it, la. If it's not resonant, you got standing waves, and it's not going to work. It's going to shut down.
It should be 50 ohms here, right? Is that
50
right?
ohms.
If it's more than 50 ohms, what do I do?
That's when we have
to have an antenna coupler
tuners.
or a
Well, you
tuner?
could do that. You could get a ballon maybe to.
Okay.
But a coupler would help. But remember, the coupler just sort of fools the radio what's going on. So
you
I
don't
would always
really
try.
want to do that. You want to make the antenna right.
Right.
No,
Yeah.
There's many times people, they put up an antenna and it doesn't work. So, I'll get me a tuner. So they put the tuner in and, wow, everything's great.
Still
But
doesn't work.
The tuner only fooled the transmitter. Really, I'm serious. It only fools the
Right.
transmitter that, I'm okay.
Right.
Didn't make the antenna resonate anymore.
Right.
You're not going to make the antenna
Should not
put
get
your
the
signal.
power you deserve. You need.
Well, it's not allowing the transmitter to conduct that output to a resonant antenna.
Right. You want one-to-one if
That's
you
right.
get
And
it.
just because the tuner's in there does not make that antenna change. And that's kind of a problem that I find with a lot of hams. They try to correct antenna.
It's just a Band-Aid on it, instead of having the right antenna.
Well, the transmitter's happy, but
So-
that doesn't make your antenna work.
Is it changing the length that's going to change it so it resonates properly? Is that the key to the whole
Changing for resonance and how this is positioned. If you get them closer than this, now you're about 30 ohms, 40 ohms,
Got it.
50 ohms, and about 70 ohms.
So
we
you
want-
can adjust these too to get it
That's
to
correct.
50.
Changes the impedance.
Yeah. And I want an SWR meter. Is that the best way to measure that?
Most radios have it built in.
Oh, that's nice. You just look at the radio.
Exactly.
Oh, that's great. And it'll say, that's 50, or that's 40, or that's 30.
It's all there. It tells you if you're 1-to-1 standing wave ratio or 1.5 or 3.1. I got a problem.
But the antenna analyzer, a good piece of equipment to have, because that'll actually let you see the feed point impedance. The SWR would just tell you, well, it's a little too long or a little too short.
Right.
Might not be able to tell as much as a good analyzer.
You know, this is great because it really is pretty simple technology, and this is a great antenna. You don't need the fancy, expensive antenna. This is a very inexpensive way to
you
get
think
great
about
results.
That's all. When you see what's on the roof here, the driven element of that
is
this. Only instead of wire, it's an aluminum tube.
Right.
But it's the same length as that.
Right.
Somewhere there's an element up there for 28 megacycles.
That's great. I love it.
It's a simple thing. A lot of people make every day. It seems like there's somebody else that has a new antenna theory, isn't it? I have this new antenna. It all comes back to this, folks. I'm sorry.
Now, what's the radiation pattern on this antenna? Is it a figure eight? It is.
Figure eight.
So it's the middle here, and it's a lobe all the way around the wire.
Let's hold it like this. Go ahead, George. Grab the other end. It's going to radiate. And actually hold it up higher.
Hold it up. There you go.
A little higher, little higher. There we go. Nice 50 ohms.
There you go.
It's going to radiate this direction and that direction. So it's a lobe like this.
So, and that's important because it radiates basically
Flat
horizontally. It's flat.
Flat side, right?
Yep.
But when we drip it down like this, now we get a little bit of radiation off the ends as well.
And when we move it down, we smush that figure eight, and so it's
That's right. Now it's
less,
just strictly figure eight.
Little
No
more omni.
smooshing off the end.
Yeah. Very cool. Well, I have learned so much, and it's so much fun. And now we made a dipole. That was about the easiest thing ever. Where do I get these?
There are all kinds of companies that make this thing. This is an Alpha Delta, but
How much is that?
I think
Probably $18,
yeah,
$20.
Not expensive.
$20.
So, and the cable you stole. So basically, this cost less than $20. We did to make this.
Yeah, we'll show you where we stole that line.
Yeah, there's more where that came
But
from.
let me tell you, don't tell John, okay?
Yeah, don't tell Alex.
Now, I'm still concerned the insulation on here is going to somehow dampen, but it doesn't. It just goes right through it.
Yeah, any kind of insulation. I never put up just solid copper. I have some kind of
Always insulated, yeah.
Yeah.
Well, it keeps the weather off it and so forth.
Yeah, and it works well. And
Thanks, guys.
always looks good.
We should do more of these. You got to come out here more often.
You got it.
We'll have more parties.
That was a lot of fun. We had a good time
that
making
was
that.
really cool.
I have a
You
couple
know,
of questions for
we
you
could
guys
have
from the
a
chat room. DJ wanted to know if you have to worry about how long that coax is. Is that going to get in the way, Gordo, of our nice new dipole, or does it matter?
No, I think it's going to be okay, but we want to keep that coax away from the main radiating elements, or else you will have a transfer of energy, and that's not good.
Okay. And let's see. Another question, I'm trying to find who it was. It was K6LCS. Do you need to aim that antenna? Do you orient it any particular way, Bob, or can you just put it up and not worry about where you're going?
There's going to be, most dipoles, as I've discovered, you got about 3 dB of directivity, and really it's, as I've found with dipoles, it's not enough to really worry about.
Got it.
You can orientate a couple of them and switch them if you wanted, but I've never found a dipole to be very directional. What do you think, Gordo?
No, if there is any directionality, it's when it's absolutely flat and way up in the air. Then it works just great, bidirectional.
All right. Well, they asked you a couple of questions. Now, Gordo's got a stumper for the chat room. Oh, and he just dropped off. We're going to get him back on Skype here. We're having his videos coming and going. Is it just his videos?
By the way,
there it is.
This is what you need right here.
Is that a standing wave ratio meter?
This
or
is a great piece of gear. It's from MFJ, and it's probably one of the most valuable pieces you can do today, and it doesn't cost very much. It's an antenna analyzer. It'll tell you exact resistance, impedance, frequency, all of the stuff. You put that dipole in there, and it'll tell you exactly where it resonates. And if it doesn't resonate on, say, 7240, what you have to do, either add resistance or add induction, inductance. It's all right here in this little box. It's really a fabulous piece from MFJ, and helpful to have, so we will have to get one of those so you can figure out what your antennas are doing.
We got Gordo back. Your stumper for the chat room, and this is a stumper for me, too.
Okay, the stumper for the chat room is, if 492 is a half wave in free space, why do we use the formula 468 divided by the frequency in megahertz as the physical half wave length of the actual wire? That makes the dipole a little bit smaller. So that's the big stumper, and the hint is K factor.
All right.
K factor.
K factor.
Yes.
And we'll come back next week and give you an answer to that stumper.
Absolutely.
Yeah.
When we were there, you know, George, it was so wonderful for him to come this weekend. We had never met him. Gordon and I.
You never met him? It was like Old Home Week. I thought you guys knew him for years.
Well, we see each other at Dayton, passing, hi, how you doing, that kind of a thing. But to sit down and chat and really get to know each other, It was a great weekend for
kidding.
both Gordo and I to spend time with George. And, of course, he was thrilled to be with you and meet everybody there. So what he did before he left is he put some video together. You know, last week he had the guy with the blowtorch. You remember that?
Yes, I do. Crazy man.
Well, that wasn't a joke. They pulled parts from that old power supply out of a computer.
Wow.
And this week, we're going to show you a piece of video that George did. And he took those parts and he's going to build a regulated power supply. He's going to do it in 2 steps. This week, he's going to build just a filtered DC power supply, and you're going to see how to do it. You have to first figure out what you want to do. And he does that well and draws you a schematic, and then he starts building the power supply. So let's take a look and see how George started with his power supply, and maybe we can all follow along and follow the whole example of how to build a DC power supply.
The first thing on our schematic is a place for the AC house current to come into the supply. Next, we'll need our power switch so that we have a way to turn the supply on and off. And we'll want to add a fuse here. I'm going to use a 1 amp fuse in this project. And now our AC supply will feed into the primary of our transformer. Now our transformer will be used to step the voltage down from 120 volts to 25 volts. Now this is an iron core transformer, so we have the 3 lines in the middle there. The primary of the transformer will be fed with 120 volts AC, and at the secondary of the transformer we'll have 25 volts AC. We'll want to convert this AC voltage into a DC voltage, so we'll use a full wave bridge rectifier, which is actually 4 diodes arranged so that we can take advantage of both halves of the 60 cycle waveform. Our AC voltage will feed into the 2 sides of the bridge rectifier, and then the other 2 legs of the rectifier will give us our DC output. The bottom leg here will be our negative voltage, and the positive leg will come out the top. Now there'll be some AC ripple still left in the circuit at this point, so we'll add a filter capacitor to filter some of that out. And I chose a 4700 microfarad capacitor for this job. And the capacitor is a polarized electrolytic capacitor, so the positive lead goes to the positive half of our supply. Now we're going to prepare the chassis and mark all our holes that we'll need to drill. We'll begin with the transformer here. We're going to need a pilot light on this project. I'm going to use an LED with a little sleeve to hold it in. And rather than get the power from the DC side of the supply, we're going to get it from the AC in the rear here, and we'll use a resistor to drop the voltage going to the LED. We'll use a pair of banana jacks for the output of the supply, so let's put marks on the case for that. I removed the little switch on the back that selects between 110 and 220 volts, and that'll be a nice place to put our fuse holder, so we'll use the nibbling tool and cut that hole out a little bigger. To mount the bridge rectifier and the filter capacitor, I'm going to use a terminal strip, and that'll go near the front of the case here, so we'll mark our hole fit. Now that all the holes have been marked, we'll pull out some of our favorite tools and have a little fun here. We're going to use the hand punch to punch most of the holes. I didn't have a hand punch die the right size for the potentiometer. Fortunately, I've got the unibit, and that really came in handy in this case. The unibit is also fantastic for deburring holes at your drill leaves. And of course, we've got to let the nibbler get into the action. When I looked in my parts cabinet, I noticed that the largest capacitors I had were 1000 microfarad and only had 2 of them, and that's probably not enough to get the ripple out of the supply, so I headed to Radio Shack to get a 4700 microfarad capacitor, which should do the job fine. While I was there, I got to thinking about my voltage regulator. It was an LM317T that was used, and I wasn't quite sure about the condition of it, although I had saved it. So I picked up another one of those. And then I got to thinking about my diodes. They're limited at 1 amp, and the regulator can do 1.5, so I decided to pick up a 4 amp bridge rectifier there. And I thought about my transformer, and I don't know the current rating on, but it was 33 volts, and my capacitor is only 35 volts. And I noticed that Radio Shack had a 24 volt transformer for just $12, so I decided to get that as well. Now I'll be able to build 0 through at least 25 volt regulated power supply that is voltage adjustable and will stand 1.5 amps of current draw. While I didn't stay true to my goal of building this supply without spending any money, at least I'll have a good little variable voltage power supply for the bench now. So let's get started. We'll mount the transformer in the case, and we'll connect the primary of the transformer through the power switch and the fuse holder. Now at this stage I want to check and see what the voltage was coming from the transformer, and it looks like it's approximately 26 volts AC, which is about what we would expect. Now this is a center tap transformer. We're not going to use the center tap here. We're going to use the 2 outer leads of the secondary so that we've got 24 volts. Now we'll mount our 2 banana jacks for the output of the power supply. Let's look at our bridge rectifier now. This is a 400 volt at 4 amp bridge. It's actually 4 diodes inside this case. And since it's rated at 4 amps and we're only going to be drawing 1.5 amps, we're not going to bother mounting it to a heat sink. It should be fine as is. And we'll mount this bridge assembly to this little terminal strip that I have. It's got 3 posts on it and 1 ground. And we'll bend the legs on the bridge and fit it into the 4 holes here through the middle, and then we'll mount our components to the terminals on the outside. The AC voltage will connect to the 2 middle terminals here on the strip, and the DC ground or negative will be on the bottom at the ground pin, and the positive voltage will come out the top pin. Now I have the bridge mounted to the terminal strip, and I've got the wires from the secondary of the transformer connected to the AC input on the bridge. It's time to add the 4700 microfarad filter capacitor. Now the capacitor is polarized, so one end has arrows pointing to it that says negative, so we'll hook that to the ground or the negative terminal of the bridge assembly, and the other lead will connect to the positive lead on the bridge rectifier assembly. Now at this point we should have a functioning 25 volt DC power supply, so let's take some measurements. And if we look at the Simpson here, it says we've got 35 volts. Well, this is unloaded, of course, and having the capacitor and the bridge in there actually increases the voltage a little bit. Once we put a load on here, we'll see that voltage come back down some. We could take this black lead, hook it up there, and the red lead. Remember how we were talking last week about a capacitor holding a charge?
See?
Well, there's a good example. Want to be careful to discharge those before you go in working on electric components that have large value capacitors.
You, George.
And this one's already discharged now. No
yes,
more
it
spark
is.
there.
That's why they call it smoke and solder. George Thomas's great smoke and solder segment, one of my favorite parts of the show. Zip.
Now, see, that was just the DC filtered part of the supply. Next week, he's going to come back and help us build a regulator so that we can regulate that and be at probably 13.8 volts, something like that, and we can use it to power all of our radios. And you can't just plug anything into those things. You want to try to keep it around 13.5 volts, and that's what the regulator will do. And what's really cool about all that, Leo, is it was stuff that he got from that old power supply last week, so you don't want to throw anything away.
Hey, guys, can I show you something I just got in the mail? I just got a box of over 1,000 QSL cards. We were talking the other day about QSL, and you know, some people now do it the modern way where they'll use the logbook of the world. I just signed up for that, but you are an old-fashioned guy, Bob, and you said send those postcards. This is a ham. Jim Sadler passed away earlier this year. His daughters Peggy and Jerry said, would you like his collection of QSL cards going back to 1939? I said I would love them. We'll give them a good home. He spoke, as you might expect, to Asia a lot. Look at this one from the Fujitsu Beam Club. Is that ham radio gear? I don't know what that is.
Wow.
Isn't that wild? All over the world. Here's the United Nations Staff Recreation Council from the UN in New York City. Here's Tonga, way down there in Australasia. These are cards that go way back in time, some of them. And I just want to thank Peggy and Jerry for sending them along. We'll give them a good home here at our Twit Brickhouse Ham Shack. And it's just, now I understand, Bob, you could do it on the computer, but you don't get this great piece of history and these great memorabilia that you would get by doing these QSOs via postcard.
I still love QSLs. I send them out when I get one. I always send it out immediately to guys and respond to them.
They're fun, too. There's a lot of Japanese hams, and he's got a ton of cards from Japan. Of course, he was active from 1939 to just last year on the West Coast in San Francisco. He was a radio operator in the Merchant Marine during World War II in the Pacific Theater. So he first got on the air from San Francisco with home-built ham transmitters and receivers in the 10 and 2.5 meter band in 1939. Some of these are just amazing. Just amazing. And one of the neat things about ham radio, of course, if he started in 1939, he was a ham during the time when we were at war with Japan, and yet this ham radio brings people together, and after the war ended and peace broke out, well, he was contacting and talking to hams all over Japan, and that's pretty cool. That's pretty cool. Look at that. These are great.
Yeah, that's the neat thing about ham radio is it's an international fraternity, and there's no politics in ham, and that's what makes it such a unique hobby and service.
It's so exciting. So anyway, I just thought I'd share some of those with you because they're just so many.
Leo, you're talking about stuff like this, right?
Yeah, look at that. You got a few of those in there too. Look at that, Bob.
You better believe it.
So I guess we'll just keep a book of them right there at the Ham Shack, and if people come in and they want to visit us, one of the things they can do is page through Jim's collection.
Yeah, that's always fun to do. Of course, my prized QSL is this one.
Oh, from the Queen Mary. I recognize those 3 stacks.
Yes. Yep. Mm-hmm. Yep. And I was very honored to be able to operate the station a lot from the Long Beach harbor there. And if anyone gets to Long Beach, you need to do that and take your amateur radio license with you, and you can operate W6RO, and that's a great thing. It's amazing.
Oh, by the way, Bob, Nate said that there had been a great influx of new operators coming aboard the Queen Mary after our last Ham Nation.
That's great.
We're going to have him back. The last time we were having some problems, and I would love to have he and a couple of the guys back again, Leo, to go through even further things about them. And I told him the next time we have him on, we're going to have him turn the cameras around and actually get on the air maybe from the Queen Mary and show you all their gear.
Oh, wouldn't that be fun?
The first time it was a history of the whole station, but I think we should have him back on and have some fun like that. That'll really be great. We also have to be aware that things are happening in the emergency sectors of amateur radio right now because of the hurricane on the coast, and we were trying to get the section manager for the ARRL, he's on the team there, Leo, and we're trying to get him on here. And Alex is telling me he just lost his internet connection.
Bill Hillendahl, who of course is very active in emergency services, and I don't know if it's related to the earthquake or what, but I suspect it might be. So,
well, Bill they're all on the East Coast.
Yeah.
And he told me earlier today, he said, I would love to be on if I don't get called out early. And now he's lost his internet connection. Well, you know what that means. It's grab my handy talkies and he's gone. He said that too. He said, I'm going to have all my gear ready to go. So if I can't make the show, I'm out with my talkie helping people that need communication. So as we speak, amateur radio is right in the middle of all of that communication communications gap on the East Coast.
Yeah.
And, we're tuned in right now, Bob, to 14.325. For those with a shortwave receiver, maybe not hams, 14.325 upper sideband. And there we can hear some of the hurricane reports coming in from the Carib.
Wow.
Exactly.
Is that Irene? I guess that's Irene coming in.
Yes.
Mm-hmm. Exactly. I talked to Bill earlier today, and he was very worried because he said, I really want to come on the show for a few minutes, but he said I might not be able to make it. And here it is. So we'll have to see what the reports are. But there you are. Amateur radio plays such an important part. Yeah, it's fun to talk to all these foreign countries and collect QSLs and all this. But when it comes to the real nitty-gritty, those guys are on it. And out the door they go with their emergency packs. They have little stations that built into packs that put on their back, and off they go. And thank God for those guys, because they just stop their life and join the world to help everything that needs any kind of help. It's really amazing, and Gordo is so involved in that, Leo. He doesn't talk much about it.
Yeah.
And like most of them, they're not braggadocious and all that, man. But I'll tell you what, I've seen his communications van, and when they have any kind of a problem out there, he's in it, man. The van, he and Susie are down the road. And it's the same thing all over the country. We have guys that have tremendous vans, and they just sit there waiting for any kind of disaster that they can help. So we're part of a great, unique bunch of characters. And when we're not chasing storms and doing that, Leo, we get to build dipoles.
Well, I have to say,
right.
that was fun. It just shows you don't need to have a lot of money or a lot of equipment to be a good ham.
Well, you bring up a great point. A great point. I get phone calls from these guys because they know where I am in my plant during the week, but I get a lot of emails, and I really regard them, and I answer them all. I want to answer a couple of things. We've had a number of hams say, wow, your stations are great, all this stuff behind you, Leo stuff, but that's tens of thousands of dollars and all this stuff. But, man, how can you do this? Gordo, tell them what you can do for $500 or less.
Well, there are transceivers available in the $300 range. In fact, MFJ actually has some for a couple $100, but you can get a 100-watt, high-frequency, 100-channel radio for about $599. I think it's the ICOM 718. LA Craft has some great ways to get started, and there are many radios in the $600 to $700 range, brand new, with used radios, a fraction of that price.
Yeah, used radio, there's a lot of them. You have to be a little careful. I always say go to a dealer that sells and deals used amateur radio gear, because then if you have a problem, they can help you, and they will help you. Not all of the amateur radio stores deal in old equipment or trade-ins, but a lot do, and they refurbish them and sell them. And a couple $100, you can be on the air. Please do not be afraid to get into the hobby thinking you can't afford it. You certainly can, and you will enjoy it just as much. I get out that little 817 every once in a while. In fact, I'll tell you a little story about that. Joe Walsh carries one on the road with him. He could take radios this big, but no, he carries a little 817, $500, and we try to get the top room of the hotel. And then
and stick a dipole out the window.
We do better than that. We do better than that. We can't drop a dipole, so we drop out a wire. And so what does he do one night? He grabs a hold. You know the covers, the stainless steel covers that cover your steak dinner when they deliver it to you.
That'd make a great little dish.
Well, there's a hole in the middle of it. So Joe ties one of this wire, and he starts reeling it out the window, okay? And boy, we put it into a tuner because it's in-fed and that kind of stuff, and then the match is right. And we're just having a big time. All of a sudden, something comes banging on the door, and I go over, and it's the security guy. He said, we're having a complaint from somebody 10 stories down. There's some kind of a metal disc beating in his window.
You wouldn't know anything about that, would you?
Yeah. We're tracing the wire up the wall, and it's coming in your window. We need to search your room,
Oh,
sir.
dear. Oh,
So we had to explain to them that we were just hams having a better time than we're supposed to have. But that's the kind of stuff you do. Right, Gordo? I mean, you make anything work, correct?
That's absolutely correct. We improvise. In fact, antennas are a great way that hams can improvise. And there are hams that have worked over 100 countries with antennas in the attic, not poking through the roof where the neighbors can see them. So for those of you that are listening or viewing that have antenna restrictions, upcoming shows, we're going to show you how to get around those restrictions and keep that energy up in the attic, safe from being too close and going on the air.
I might want to do that. I want to get that DXCC, that 100-country DX award. That would be pretty cool. We have Bill Hillendahl, I think, on the line. Yeah, I think he's got his internet access. So let's say hello to Bill Hillendahl. He is the ARRL section chief here in the San Francisco area, and he's on a mission. Bill, are you there? Oh, that's Bill Morine.
Hello.
I thought it was. I'm sorry. I thought it was Bill Hillendahl. It's Bill Morine from the Public Relations Chairman. Hello, Bill Morine.
Hello, Leo. Hello, Gordo. Hello, Bob. And hello, everybody on Ham Nation. First of all, congratulations to one and to all on the new studio.
Thank you. Thank you. You got to come visit us, Bill.
Absolutely. And I want to publicly thank your lovely producer, Lynn. She's been extremely patient as we try to do some last-minute maneuvering here to get the Skype connection tonight.
Where are you right now?
I'm currently in my home. I had a connection. I had to move to another computer with Skype, but we're here and we're online.
And where is your home?
Home is in Wilmington, North Carolina. If you look at a map of North Carolina, you look at the coast, and you look at that point at the southern side that juts out furthest to the east. That's where we are. They named a movie after us, Cape Fear.
Oh, dear. I remember. With
Oh,
Robert
dear,
Mitchum.
Cape Fear.
I remember that
That's
quite
right.
well.
That's right. So that's where we are this evening.
Are you bracing?
And, Bill, how about telling us what hams are doing in preparation for Irene? I believe that's the name of the hurricane, making its way up the coast. Go ahead, Bill.
It is, and we've had two events today in preparation for Irene, and in addition, we've also had, as you know, the 5.8 earthquake that hit in Virginia just north of us. And yes,
Wow.
I felt the vibration here. Now, those of you who are veterans of the California scene, this was nothing, but this was revelation to us on the East Coast.
We're sharing.
What we do is this will be my 8th major hurricane through which I've been. And the preparation is getting better and better, not just for me, but for all of amateur radio and particularly for Aries right now. We are now 96 hours out from expected landfall. And I want to give compliments to the National Weather Service and NOAA for the type of improvements they've had in their weather forecasting over the past few years. As many of you may know, hurricane tracking has improved dramatically. The one thing that is still lacking is not tracking, but the level of intensity of the storm as it hits. And hurricanes are interesting because they are one of the few disasters, perhaps along with floods and winter storms, for which you can do some advanced preparation. Many other types of disasters are ones that come unexpectedly. So we do have the benefit of doing that. To answer Gordo's question specifically, we have put our statewide, which is also coincides with our section, HF Aries Net on standby. And we started this evening with that. Local emergency management organizations in the eastern part of North Carolina, and North Carolina has 100 counties, so approximately 33 of those counties are in some kind of elementary mode right now. As many of you may know, the track of Hurricane Irene has thankfully shifted further to the east, and right now the only part of North Carolina tonight forecasted to have impact would be the extreme eastern section, which is also in the northeastern part of the state, and everyone knows that as the Outer Banks. So we're battening down the hatches here.
You have a whole team of guys ready to go. I know that you have some equipment all packaged and ready. Have you called any of those guys out, or are any of those guys on scene just yet?
No, it's too early, and that's part of, I think, the level of expectation, Bob, that has come with this. And I want to make sure that viewers understand that even with a predictable disaster, such as the one like Hurricane Irene or another major hurricane, that you can almost people's expectations are raised so high because there's still a lot that can go into the forecast that may mitigate what it is that you do. I think a prime example right now is that, as you can imagine, if you prematurely open up resources, particularly shelters, start rescheduling governmental events, that's a tremendous cost, and the need for the advanced planning may not yet be there. For example, the first tangible site that we saw that some type of planning was going on, believe it or not, Friday night high school football games have been rescheduled to Thursday evening here. That may seem like not very important, but that is a big thing to reschedule those. The first series of major governmental briefings comes usually 72 hours in advance of landfall, and then also notification of amateur radio need may come officially as little as 36 to 48 hours in advance. And so we really were ahead of the curve right now. So to answer your question, no, nobody has been called out. We may not get the official notification to, for example, staff shelters until maybe 24 hours prior to landfall. So we're very much in a standby and wait mode.
Well, we're sure glad that you still have all your electricity and things are going well there for right now. And everybody appreciates what all the emergency guys do, because I know you guys drop everything you're doing and off your run when things really get serious. And I appreciate very much you coming on the show tonight. And thanks so much to Gary Pierce. You'll hear Gary next week. Gary's going to sit in for me next week, KN4AQ. He's been here before, a very wonderful guy. And he was the one that sent me the note with your contact information, and I appreciate him hooking us up so you could come on Ham Nation and let people know that even though there are disasters around the corner, we've got people looking out for us all. So thanks very much for what you and all of your folks there are doing in North Carolina tonight. That's great.
And, you know, the American Radio Relay League has quite a cache of radio equipment that they are preparing to send down just in case if things really get bad. So good for Bill and his parent organization, ARRL.
Thank you all very, very much. I hope you all have a great evening, and my appreciation to everyone at Ham Nation. Again, congratulations on the new studio, and may it bring you many great broadcasts ahead.
Thank you so much,
Thanks,
Bill.
Bill.
Great to talk to you.
Have a good night.
We were talking about the new station, and I've got a new addition coming pretty soon to the Ham station. We were talking, of course, we've got that great Collins transmitter, Bob, but I just got an email from David Jennings and Mike DeRoe. They found me a new mixer. You know that Gates Stereo Statesman that I used when I first started out in radio? Take a look at this. This is to give you an idea of how much work Mike DeRoe puts into one of his pieces. This has obviously been sitting somewhere in a basement for a long time. The inside is corroded. The wiring is broken. It's not functional.
Wow.
He takes it apart. He uses toothbrushes and paint and all the restorer's tricks. And look at this. A brand new, shiny new, better than new Gates Stereo Statesman. This is the console that I used when I first started in radio.
Isn't that something?
And we're going to trade that in for the, we're going to send back the very nice Collins that David Jennings gave us from his own operation, and we'll be replacing that. Now I just need 2 turntables and a cart machine.
And a tape recorder.
And I think I know somebody who might have an Ampex tape recorder lying around.
Yes.
Yeah, maybe 2 of them.
One will do.
Well, I get to keep one.
You keep one, and I'll buy one from you. But we're going to have a beautiful little radio station over here.
It's just a real passion for Mike DeRoe and for David Jennings. And there are a number of guys that they just eat, sleep, and breathe to be able to treat that old gear like a classic car. They completely restore it and bring it back to life where it's been discarded and thrown away, and that's not fair. So get you on 3870 and 3880 and
I can't wait.
all those good frequencies. Oh, it's going to be fun, but we'll get there. We'll get there.
It's a lot of fun. Hey, before we go, Gordo, I want you to repeat your stumper for this week so people can put their thinking caps on and answer your question. We're having a little trouble with Gordo and his Skype. We just lose the video, right? We keep the audio.
Yeah.
Okay.
Yeah, we still have audio.
All right.
All right, the question is, if 492 divided by the frequency in megahertz computes to a half wavelength in free space, why do we build our dipole that you did so well using the formula 468 divided by the frequency in megahertz in a physical length of wire, which would make the dipole a little bit shorter? Why do we do that? And the hint is the K factor. That's our stumper for the week.
I love that. We're going to start doing this every week. We're going to get a email box set up for that, too. I want to do that. And I had promised, and I haven't gotten on it, but I will get you guys email addresses, too, so that people can email you directly. But you can always email your suggestion or your answer to me. I'm Leo at w6twt.org, and I'll forward them along to Gordo and hope somebody gets that one right. No looking it up on Wikipedia. I don't know if you could look that one up on Wikipedia. You have to use your noggin on that one, I think.
Well, it's going to be fun bringing all this great technical jargon to a lot of the beginners, and they need to know this. But some of us old characters too that didn't ever quite understand it or didn't have the Elmers. But we're here, and we also are going to start spending a little more time with the chat room and Ask the Elmer, as we're going to call the segment. But
can't wait.
Tonight we had to bring Bill in and talk about the hurricane that he's preparing for. I thought that was very beneficial. So we'll be there for all you. But you can contact Gordon and I with our call signs at ARRL.net. We've got it across the bottom of the screen somewhere once in a while. Look us up on QRZ.com. That's another ways. Or you can just pick up the phone and call us too. You know, that works. Well, listen, we've had a great program tonight. I'm so happy you now have a dipole. And somebody asked a while ago, is it up? No, it's not up yet. We're still trying to find a noiseless place around the studio to hang it.
Well, we're a little afraid that the local utility might be using BPL on those smart meters, broadband over power line, which of course would be causing an awful lot of RF interference on the high frequency band. So it might be something that we can't fix except by getting a remote antenna, but we're going to figure that out.
Yeah, we got people working on that, and we really appreciate that. We've had a wonderful time this weekend in Petaluma. It was just so much fun. Leo, thanks so much for inviting Gordon and George and I and spending a little time with us. I know you were so busy. Everybody was tugging at you, but boy, you never forgot your ham radio buddies, let me tell you.
I was there every minute, every time I could. I came out and watched, and it was so much fun, and you learn so much. This is something I'd like to pass along to. I know there are lots of people watching who want to get their ham licenses and want to get involved in amateur radio. You learn so much by watching an experienced ham do what they do. It was so great, or just even listening on the bands, but watching somebody work is really fascinating. If you could find an Elmer near you, hams are the friendliest people I've ever met, and just hang out with them. They'd love to show you their shack. I'm sure they'd love to show you what they do, and you can learn so much just by watching. So I was very grateful to have both of you guys out here. I'm so excited.
It was so much fun, and we want you guys to send pictures of your shacks in now. We're starting to build quite a resume of that too, but we'll start showing some of those too as we get further into the program, and see what other kinds of fun we can get into. Leo, thanks a lot. And Gordo, good night to you in Costa Mesa. And good night to all of the staff there in Petaluma. And I already hope I can come back. Nobody's told me I can't yet.
You can come back. And I love it that every time you're on, your microphone, you have a microphone to match every shirt. So
well,
I
we
think
have a custom department at this little company that I work for down the path here, and the guys build me all kinds of different colored microphones. And we do that for lots of people. So we're gonna say,
well, you did it for me. I have a beautiful gold microphone thanks to you.
I don't have a gold one. Stephen will not do it for me. He said only for Leo.
Well,
good night, everybody. 7-3. We will see you next week right here on the good old Twit Network with another edition of Ham Nation for the ham radio fanatics, where we have a lot of fun, a little high, a little low, but we're somewhere in there, and we'll continue to have fun here on the good old Twit Network.
7-3, everybody. 73, Gordo.
73. We'll see you next week with Don Arnold, all about APRS.
And a QCL for the night. Actually, stay tuned because NSFW is coming up.
All right.